start Okay, Lokesh, the floor is yours.
Thank you, Prof. Good afternoon, everyone. As per Prof said, like here, in image A, we can observe like electromagnetic radiation is being explored in the high amount of exposed in environment. And in image B, we can see like shielding effectiveness being arranged in small area, so it is opposing the radiation of electromagnetic to allows very less amount of radiation out of this shield. So shielding effectiveness, which being like used like a layer, which when the frequency was incident on the particular layer, it has been transmitted, observed, and reflected. As we observed in shield layers, we here like in the three layers was used, and for suppose like if we see the incident waves are in three waves were entering into the first layer, which is being reflected and observed and reflected inside the layer 2, and again it's transmitted and observed and reflected by the signal due to the material, and after that it enters a few amount of the radiation enters to the third layer, and which reflects and transmits to the other side of these three layers. As for shield effectiveness, here we use the formula like shielding effectiveness will be equals to the reflection, absorption, and M, which stands for the continuation, reflection, and transmission. In implementation, as per our project, the aim of project is composition of shielding effectiveness by using layers with different materials, which opposes the radiation through to check the propagation using four different tasks. Here we used programming language Python because it is a high-level object-oriented language and which supports the modules and packages. And the uses are like code console we have, and kernel backend we have, and live documentation we can perform, and the environment Jupyter lab we supported for this code. As now I said, like the Python code being implemented in a module of 5 layers module, as which is act like a shielding effectiveness. We arranged these 5 layers: A, Teflon, cement, Teflon, and A, which has a differentiation of thicknesses. As per the simulation, we took the libraries according to the Python, which supports very good in CPy, which is try to help us to optimize and lead linear algorithms and supports to the imaging process as well. And the NumPy is another library which is 50 times faster than conventional in the Python list. And matplotlib is a library which supports us to graph very well, which we got obtained the signal results according to our analysis. COMPI is the common programming interface in C language, but even though it supports to the Python, which helps us to do the analysis and array things. As per our result, like we perform like 4 tasks. The first task, which we use like 3 layers, which arranged in A, Teflon, and A. For example, if we can see here, like the signal is passing through these 3 layers and reduced being into small amount of radiation, which is output of the other side of the layers. As per we observed here, the decibel, like shielding effectiveness being assumed in decibels, and we used the frequency of 10 gigahertz, and shielding effectiveness is being opposed the signal till the 1 decibels. As per our task 2, here we used like A, cement, and A, 3 layers, and the signal is passed. When the signal is passes, it reduced a more bit signals compared to the fast task because it has high permeability and conductivity compared to the Teflon. So we can observe in the graph as well, the shielding effectiveness is started from point 0, and the frequency at frequency 4, it's being increased and it's stable in the constant till the 10 gigahertz. As per task 3, here we use like 4 layers, 8 Teflon, cement and air, and we can see the differentiate thickness of air, the first layer and the fourth layer. And here the shielding effectiveness being opposed more radiation as per our result, like it started from 5 and it reaches 8 decibels of shielding effectiveness in the range of 6 to 8. As per our task 4, this is the final our aim to produce like 5 layers of shielding effectiveness, which is better to reduce the radiation. So here we can observe like most of the radiation being opposed in the range of 6 to 8, and the level of shielding effectiveness in 9 decibels. As per our conclusion and future scope, the conclusion like the Python code being analyzed successfully by using the shielding effectiveness by implementing our layer model using different materials. As per our future scope, like finally we are planning to improve the material and analysis process by differentiating by the thicknesses of our materials. Thank you.
Just a curiosity. So you developed this open source software-based simulator,
Yes.
but does it use the same finite element approach as commercial simulators, I don't know, like ANSYS, or it uses a different approach?
Yes, because here we use like the Python which supports to the Jupyter Lab environment, and we can do the live editing and live simulation at the same time period. And why we use this in particularly means like it has a debugging rate will be higher compared to the other programming languages. So we can debug the program automatically by the Python feature. So it will be more easier to simulate as much as we can do from the project.